When you look up into the sky on a clear day, you see it. The sun. It's easy to take it for granted, isn't it? Just a big light bulb in the sky. But the sun is so much more than that. It's a star, our star, the very heart of our solar system. It's a colossal sphere of incandescent gas, seething, churning powerhouse that dictates everything for us here on Earth. Its sheer scale is almost beyond comprehension. A true giant in our cosmic neighborhood. It's the source of all our light and all our warmth. The sun isn't just big, it's astronomically enormous. It contains over 99.8% of all the mass in our entire solar system. Imagine that, all the planets, all the moons, all the asteroids and comets. They are just tiny specks of dust compared to the sun. Jupiter, the largest planet, is still 1,000 times less massive. This incredible mass gives the sun its immense gravitational pull. It's this gravity that holds all the planets, including our Earth, in their orbits. Our sun wasn't always the brilliant star we see today. Its story begins a very long time ago, about 4.6 billion years, in fact. Back then, in this part of our galaxy, there wasn't a sun, there wasn't an Earth. There was just a vast, cold, dark cloud. A giant cloud of gas and dust, mostly hydrogen and helium, drifting through space. This is what astronomers call a molecular cloud. These clouds are the nurseries of stars. They are the places where new suns are born, scattered throughout the Milky Way. It's a quiet, almost empty place, yet it holds the seeds of future brilliance. Then something disturbed this peaceful cosmic cloud. Perhaps it was the shockwave from a nearby exploding star, a supernova. Or maybe the gravitational nudge from a passing star. Whatever the trigger, it caused parts of the cloud to begin to collapse. Gravity, that ever-present force, started to pull the gas and dust particles closer together. As the cloud contracted, it began to spin faster and faster, just like an ice skater pulling in their arms. The material in the center of this collapsing region started to clump together, growing denser and hotter. This was the very first stage of our sun's formation. The sun might look like a perfectly uniform ball of light from our vantage point on Earth, but if we could somehow peel back its layers, we'd find a complex and fascinating internal structure. It's not just a homogeneous blob of hot gas. It has distinct regions, each with its own characteristics and vital role to play in the sun's existence. Think of it like a celestial onion, with layers upon layers all working together. Understanding these layers helps us understand how the sun generates its energy and how that energy makes its way to us across 93 million miles of space. It's a journey from the core outwards. At the very heart of the sun lies the core. This is the sun's engine room. It's a region of unimaginable conditions. The temperature here is around 15 million degrees Celsius. The pressure is over 200 billion times Earth's atmospheric pressure. It's so dense that a thimbleful of core material would weigh more than a car. So, what exactly is this incredible process happening deep within the sun's core? How does it produce so much energy day after day for billions of years? It's not burning in the way a log fire burns. If the sun were made of coal, it would have burned out long, long ago. The secret to the sun's power lies in the most fundamental forces of nature. It's a process called nuclear fusion. This is where the true magic of the stars happens. It's the universe's ultimate power source, and our sun is a magnificent example of it in action. At the heart of the sun, the immense pressure and temperature force hydrogen atoms, the simplest and most abundant element in the universe, to overcome their natural repulsion. Our sun might seem like a constant, unchanging source of light from our perspective here on Earth, but when we look closer, using specialized telescopes, we see a very different picture. The sun is a dynamic, ever-changing star. It has moods, it has weather. We call this solar activity. These phenomena are driven by the sun's powerful and complex magnetic fields, which are generated by the flow of electrically charged plasma within its convective zone. These magnetic fields twist, stretch, and sometimes snap, leading to spectacular events on the sun's surface and in its atmosphere. One of the most well-known features of solar activity is sunspots. These are temporary dark patches that appear on the sun's photosphere. They look dark because they are cooler than their surroundings, though still incredibly hot, around 3,500 degrees Celsius. compared to the photosphere's average of 5,500 degrees. The sun is far more than just a beautiful object in our sky. It is, quite simply, the giver of life for our planet. Without the sun's constant and reliable output of energy, Earth would be a vastly different place. It would be a frozen, dark and barren rock, hurtling through the cold emptiness of space. Life as we know it, in all its wonderful diversity, would be impossible. The sun's energy is the fundamental driving force behind almost every physical and biological process on Earth. Its importance cannot be overstated. It is woven into the very fabric of our existence. Our sun, like all stars, has a life cycle. It was born, it is currently in its stable middle age, and one day it will die. Right now, our sun is about 4.6 billion years old, roughly halfway through its main sequence lifetime, where it steadily fuses hydrogen into helium in its core. It's a G-type main sequence star, often informally called a yellow dwarf. This period of stability has been crucial for the development and evolution of life on Earth. For billions of years, it has provided a relatively constant output of energy, a reliable cosmic partner for our planet. But this stability won't last forever. In about 5 billion years, the sun will run out of hydrogen fuel in its core. When this happens, gravity will begin to compress the core, causing it to heat up even more. This intense heat will cause the sun's outer layers to expand dramatically. It will swell into a red giant. Thank you for watching. Hope to see you in next video.